Let us start NCERT questions and examples. Now in this question, example number 10 here, there are these angles, pi by 6, pi by 3. So you should be very comfortable with this, that pi by 3 is nothing but 60 degrees. So pi by 6 is nothing but 30 degrees, because pi is 180, right? So sixth of it will be 30 and third part of it will be 60 degrees. And what about pi by 4? Pi by 4 is 45 degrees. I hope you should have these things in your mind. Now there is one of the angles as 5 pi by 6. So sine 5 pi by 6 is there. So what you can think about this angle is that you can write it as sine pi minus pi by 6. And we know that sine pi minus theta, now this is even multiple of pi by 2 or multiple of pi. So it will not change sine into cos. So sine will remain sine, and this falls in second quadrant where sine is positive. So it will be equal to sine pi by 6. So sine 5 pi by 6 is nothing but sine pi by 6. Now tell me whether you can solve this question or not. 3 sine pi by 6, that is sine 30, which is 1 by 2, into secant pi by 3, which is secant 60, which is reciprocal of cos 60. So cos 60 is 1 by 2, reciprocal of it will be 2. Then minus 4 sine 5 pi by 6, which is nothing but sine pi by 6, that is sine 30, and it is equal to 1 by 2. And this is cot pi by 4, that is cot 45, reciprocal of tan 45, which is 1. So it is also 1. So this is my left hand side. And let us see what is the value that I have. I'll have 3 from here and 2 from here, right? This is 2. So 3 minus 2 is equal to 1, which is my right hand side. And this is what I had to show here. So you should be comfortable with angles in radians, as well as you should be able to think in terms of degrees, right? And you should be able to think about radians independently also. You don't have to always convert them into degrees. So you should be like, you should practice so much that you are comfortable with the radian measures also. Sine 15 degrees can be written as sine 45 degrees minus 30 degrees. And now I'll apply a formula of sine A minus B, which is sine A cos B minus cos A sine B. So this is a pretty simple idea, that it will be equal to sine A cos B minus cos A sine B. So it will be equal to sine 45, that is 1 by root 2, cos 30, that is root 3 by 2, 1 by root 2, sine 30, that is 1 by 2. So if you can write it collectively, you will write it root 3 minus 1 divided by 2 root 2. So this is a formula for sine 15 degrees. Or this is the value of sine 15 degrees, which you can also memorize. Now in this question I need tan 13 pi upon, this is 12, okay, there seems a printing mistake, so this is 12. So you can consider it like this: tan 12 pi plus pi in the numerator and then 12 in the denominator. So it is nothing but tan, now 12 pi by 12 will become pi, so pi plus pi by 12. Now here I have got pi, so it will not convert tan into cot, tan will remain tan. Now look at the quadrant, pi plus theta, so it is in third quadrant where tan is positive, so it is equal to tan pi by 12. So what is pi by 12? It is, if you think in your mind in terms of degrees, if you are more comfortable with degrees, then this is tan 15 degrees. So you can write it as tan 45 degrees minus tan 30 degrees. Right? Now you just need to apply that formula for tan A minus B. Tan A minus B, which is tan A minus tan B divided with 1 plus tan A tan B. right? So it is tan pi by 4 is 1. Let me write it in red color. Tan pi by 4 is 1 minus this is tan pi by 6, that is tan 30 degrees. So 1 by root 3 divided by 1 plus this is 1 and this is tan pi by 6, which is 1 by root 3. So it will give you root 3 minus 1 divided with root 3 plus 1 as your answer. Okay. Now there is this left hand side and we have to bring it equal to right hand side. So let me use the left hand side and write the formula for sin x plus y directly, which is sin x cos y plus cos x sin y. And in the denominator I have sin x cos y minus cos x sin y. Now if you notice, what do you require? You require tan x plus tan y, all of these terms in tan. So you think in your mind, what do I divide these terms with so that I can bring them in form of tan x plus tan y? So you have to divide each of the terms with cos x cos y. So if you divide each of the term in numerator as well as in denominator with this same expression, you will not change anything in the expression, right? Or you can say that that expression, the resulting expression, will be equal to this expression. So if I divide this term with cos x cos y will be cancelled and tan x will be the answer. When you divide this term with cos x will get cancelled and you will have tan y here. And in the denominator, if you divide this term with cos x cos y will get cancelled and you'll have tan x here. And here if you divide it with cos x will be cancelled and you'll have tan y. So this is nothing but my right hand side. So hence it is proved. This is a very important expression, right, which can be obtained from this formula, tan x plus y. What is it equal to? This is equal to tan x plus tan y divided by 1 minus tan x tan y. So what I can do here is I can write tan 3x as tan 2x plus x, right? Furthermore, you know, if I replace y with x, I'll have a formula for tan 2x, which is 2 tan x divided by 1 minus tan square x. So now if you know this and this, you can very well find this tan 3x, which is tan 2x plus x. So you can write it as tan 2x plus tan x divided with 1 minus tan 2x into tan x. Okay, this is something, the question is done. Okay, you don't have to do anything apart from the manipulation part. Now this is, let us say, left hand side and this is written on right hand side. Now I am cross multiplying. So when I multiply this denominator with tan 3x, what will I have? I'll have tan 3x minus tan 3x into tan 2x into tan x, and it will be equal to this tan 2x plus tan x, tan 2x plus tan x. Now what do I require on the left hand side? Tan 3x, tan 2x, tan x, which is this. So I'll take this on one side and rest of the terms on other side. So it will be equal to tan 3x into tan 2x into tan x will be equal to tan 3x minus tan 2x minus tan x. Okay, pretty simple. Now remember, we have learned a formula cos C plus cos D, right, which is equal to 2 cos C plus D by 2 cos C minus D by 2, right? Now consider this as C and this as D and apply this formula here on the left hand side. So my left hand side of the given expression will be equal to 2 cos c plus d. When I add this and this, x will get cancelled, and pi by 4 plus pi by 4 will become 2 pi by 4, that is pi by 2, right? I have written this much part by now. Now I'll write cos c minus d by 2. So cos c minus d. Now when I subtract these, pi by 4 will get cancelled, x minus or minus x will give me 2x here, right? And now what is this cos pi by 2? Cos pi by 2 is, I think I have made a mistake here. What is the mistake? That when I added these, I did not divide it with 2, right? That is why I got cos pi by 2, which is 0. But cos pi by 2 divided by 2, this is something I forgot. So cos pi by 4 will be here, and I'll have to divide this by 2. So the expression that I'll have is 2 cos pi by 4 into cos x. Okay, now it is the correct expression, I think. Now what is cos pi by 4? It is 1 by root 2. So I can write it as 2 into 1 by root 2 into cos x. So which is root 2 cos x, and which is my right hand side, right? So I was not very careful while doing this calculation. That is why this mistake. So you have to be very, very careful. What you can do is, you can write this complete step like this: pi by 4 plus x plus pi by 4 minus x, then divided by 2. Now you will not miss that. So this is pi by 2 divided by 2, so you'll get pi by 4 here. Alright, let's move to the next one. Again, I'll apply the formula that we just applied on this left hand side. In the numerator, I'll apply cos c plus d, and in the denominator, I'll apply sine c minus sine d. Now it is on you whether you have memorized these formula or not. If you have memorized these, you can write the left hand side as, now this is 2 cos c plus d by 2. 2 cos c plus d, that is 12x by 2, so it will become 6x. Cos c minus d by 2, so 7x minus 5x, 2x divided by 2, so it will have x here, divided with, this is sine c minus sine d, so it will give you 2 cos c plus d by 2, that is 7x plus 5x by 2, that is 6x, and then sine c minus d by 2, that is 7x minus 5x, 2x by 2x. So this will be cancelled, this is already cancelled. So cos x by sin x will give you cot x, which is my right hand side. Okay. Now in this expression, in 7th example, left hand side is sine 5x minus this 2 sine 3x, then plus sine x. If you notice, if I apply CD formula on this and this, sine 5x plus sine x, then I'll have a term which is average of these, 5x plus x by 2, so which is this one. So whenever you have got this kind of expression, you choose terms to apply CD formula. So I choose these as sine 5x plus sine x, because if I apply CD formula on this, let us see what I have. 2 sine c plus d by 2, that is 5x plus x by 2, that is 3x, cos c minus d by 2, that is 4x by 2, 2x. Okay, one of the terms is this 2 sine 3x, which is there at this place, so I'll be able to manipulate it easily, or I'll be able to take something common from these. So let me write this result here in the numerator. Sine 5x plus sine x, I am writing at this directly, so let me write it as 2 sine 3x cos 2x, and then this second term minus 2 sine 3x. Okay, let's go to the denominator now. Cos c minus cos d. Cos c minus cos d was minus 2 sine c plus d by 2 sine c minus d by 2. So let me take this minus here. Sine c plus d by 2, 5x plus x by 2, 3x. And then sine difference, that is c minus d, 5x minus x, that is 4x by 2, so it will be 2x here, right? Now if you see in the numerator, I can take 2 sine 3x common, and inside I'll have cos 2x minus 1, and in the denominator, if you see, I have 2 sine 3x here into sine 2x. So I can cancel this and this, right? And in the right hand side, you see I need tan x, right? So let me open these terms like this. What is cos 2x? Cos 2x can be written as 1 minus 2 sine square x, right? And then there is minus 1 divided with minus sine 2x. Sine 2x can be opened as 2 sine x cos x. Now this 1 is cancelled. In the numerator you have minus 2 sine squared x. In the denominator you have minus 2 sine x cos x. So one of the sines will get cancelled. This minus 2 will get cancelled. I'll have sine x by cos x, which gives me tan x, and it is my right hand side. If you see in these questions, you just have to place the values of these angles, right? This is sine square of pi by 6, so it is 1 upon 2 squared. If you know value of sine pi by 6, then you can do it very easily. Now cos pi by 3 is also 1 by 2, so you'll have to write 1 by 2 squared. So I'm writing this left hand side here, minus tan square pi by 4, so it is 1 squared, which is 1 itself. So this is my left hand side, so it is equal to 1 by 4 plus 1 by 4 minus 1. 1 by 4 plus 1 by 4 is 1 by 2. 1 by 2 minus 1 is minus 1 by 2, which is right hand side. In this second part, or the second question, again I have this sine square pi by 6, so twice of 1 by 2 squared. You just have to replace these values. Now I have got 7 pi by 6 here. What is 7 pi by 6? 7 pi by 6 is nothing but pi plus pi by 6, right? And there is this pi, so it will not convert this ratio. Cosecant will remain cosecant, but now you see this is third quadrant. In third quadrant, cosecant is negative, so what will happen is I can write this as minus cosecant pi by 6, right? But there is this square, right? So if I square this, it will again become positive. Now what is cosecant pi by 6? I know sine pi by 6 pretty easily, that it is 1 by 2. So cosecant pi by 6 is 2, and square of it is 4. So 4 here. And cos pi by 3 is 1 by 2. Cos pi by 3 squared, that is 1 by 2 squared, which is 1 by 4. So this is my left hand side, and this is my left hand side. So 2 into 1 by 4 plus 4 into 1 by 4, which is nothing but 6 into 1 by 4, that is 3 by 2, and it is my right hand side. Alright, now here I have got cot square pi by 6, so it is root 3 squared plus, this is cosecant 5 pi by 6. What is 5 pi by 6? This is pi minus pi by 6. If you notice, this is second quadrant, so cosecant will remain positive and pi will not change cosecant into secant. So what will happen is you can write this as cosecant pi by 6. Okay, and what is cosecant pi by 6? It is reciprocal of sine pi by 6, so it will be 2 plus 3 into tan squared pi by 6, so it is 1 by root 3 squared, and this is my left hand side, so it is equal to 3 plus 2 plus 3 into 1 by 3, so it is equal to 3 plus 2 plus 1, which is 6, which is my right hand side. Now look at the fourth question here. What does it tell me? Sine square 3 pi by 4. So this is 3 pi by 4. I can write it as pi minus pi by 4. Right? This is 3/4 of pi. So I have to subtract 1/4 from pi to obtain this. Okay. And sine pi minus theta is sine theta. So it is equal to sine pi by 4. Sine 3 pi by 4 is equal to sine pi by 4. So what I can write it as is left hand side as twice of sine square pi by 4, which is 1 by root 2 squared, plus 2 cos square pi by 4, that is 1 by root 2 squared, plus 2 secant square pi by 3. So if you are not comfortable with secant, you can think in terms of cos. What is cos pi by 3? It is 1 by 2. So what will be secant pi by 3? It will be 2. 2 squared will be 4. So 2 into 4. It is equal to 2 into 1 by 2 plus 2 into 1 by 2 plus 8. This is 1, this is 1. 1 plus 1 plus 8, that is 10, which is my right hand side. Sine 75 degrees can be written as sine 45 plus 30. So it is sine A cos B plus cos A sine B. Now this is 1 by root 2. This is root 3 by 2. This is 1 by root 2. This is 1 by 2. So you can write it as root 3 plus 1 divided by 2 root 2. Tan 15 can be written as tan 45 minus 30. So this is tan A minus tan B divided with 1 plus tan A tan B. Now tan 45 is 1, so I'll write it as 1 minus 1 upon root 3 divided by 1 plus 1 upon root 3. So it can be written as root 3 minus 1 divided by root 3 plus 1. Okay. If in some of the books you do not require a radical sign in the denominator, you can very well rationalize it, the denominator. So you can multiply the numerator and denominator with root 3 minus 1. So what will happen is the numerator will become this is a minus b whole square. So a squared plus b squared minus 2ab, that is 2 root 3. And in the denominator, if you see, this will be rationalized. So a plus b, a minus b. Root 3 squared 3 minus 1 squared, that is 1. So 4 minus 2 root 3 divided by 2 will give me 2 minus root 3 as my answer. Right? This was a perfect answer. This is also another way to write this answer. Okay, if you look at this pattern, this is cos A cos B minus sin A sin B, right? You need to take care of these angles. If this angle is here, this same angle is here. This angle is here, the same angle is here. Cos A cos B minus sin A sin B. What is this? This is cos A plus B, which is pi by 4 minus x plus pi by 4 minus y. This is a formula for cos A plus B, where A is this angle, B is this angle. So the left hand side can be written as cos of pi by 2 minus x minus y, or if you want to write it as this, you can do that. Okay, so this is my left hand side, which is nothing but cos pi minus theta, pi by 2 minus theta. So it is equal to sine of theta, which is my right hand side. Okay, let us do rest of the questions in next lecture.